competitive inhibitors and non-competitive inhibitors. And again, this is a kind of a area where you find a lot of exam style questions around. All right, this seems to be the area that a lot of people enjoy learning about as such. So when you think of, again, biology steeped in language, think of what the word inhibitor means. Okay, so to inhibit something, you're preventing something from happening. Okay, so as it says here, an inhibitor is a substance that reduces the rate of an enzyme reaction. Okay, and sometimes it prevents that enzyme reaction from completely occurring. So we're going to look at how the different types of inhibitors work, so competitive and non-competitive, and then we're going to look at what we mean by this rate of enzyme reaction as such. Okay, so number one, when we talk about competitive inhibitors, so again, we've got our enzyme here. Here is our active site. Here is our substrate, our specific substrate for this enzyme. And here's our competitive inhibitor. Okay, and what you'll notice is the competitive inhibitor, okay, can bind on to this active site. Okay, so the competitive inhibitor, so binds on to the enzyme's active site, okay, and therefore creates this enzyme inhibitor complex. So just as what we discussed previously about the enzyme substrate complex, the inhibitor can bind on. And obviously if the competitive inhibitor binds on, we therefore get no end product, because it isn't the substrate that's going to break up into the products that we require for this reaction as such. Okay, so the competitive inhibitor competes for the active site at the enzyme and blocks the substrate from being able to bind on and can create our products. So again, if you look at the diagram here, the graph here, so increasing substrate concentration and then relative rate of reaction, so a rate of reaction. So your question could be, well, what we can do is we can just flood this process full of substrate, and then some of the substrate will therefore be able to get to the enzyme, and you would be right. Okay, so shown here our rate of reaction in relation to putting more substrate concentration in. Yes, without the competitive inhibitor, the reaction rate would occur, but as we mentioned previously, it will still get to a point where it would tail off. Okay, the reaction will stop as all the active sites are used up. Okay, however, when we've got a competitive inhibitor present, okay, increasing the substrate concentration does work to a degree, but it's going to be a lower rate because of this competition. So this competitive inhibitor is going to compete for this active site. Okay, so you're not going to get the same rate of reaction, because if you imagine it's like a 50-50, some of the substrate will bind on to the active site in the enzyme, and some of them won't, because it will be blocked because the competitive inhibitor's there. Okay, and then our non-competitive inhibitor. So the non-competitive inhibitor is still trying to inhibit this reaction, but it's not competing for the enzyme site. Okay, so here is our enzyme. Orange represents the active site, and then what's going to happen is, oh, I've just realised I put the active site on the outside of my enzyme there, and then inside of my enzyme there. Anyway, so here we have our normal substrate that we'd want to come on and bind onto our enzyme, and here is our non-competitive inhibitor. So a non-competitive inhibitor is not structurally similar to our active site in our enzyme. And it doesn't matter, because what it does is it actually binds to another area of the enzyme. Okay, it does not bind onto the active site. However, what happens is when that inhibitor attaches itself to that enzyme, okay, it therefore alters the shape of the active site. So it denatures the natural structure of that active site. And if that is altered, then that therefore means the substrate can no longer fit, which means you're not going to get any form of reaction. And this is where it's different in relation to a competitive inhibitor. So by increasing substrate concentration, okay, it's not going to make a difference at all, purely because the substrate can no longer bind onto the active site because it's been completely denatured. Okay, so increasing substrate concentration, relative rate of reaction. So here is our non-competitive inhibitor being absent. So same as before, you're going to get a nice rate of reaction till all the active sites are full. However, very, very low here when you've got your non-competitive inhibitor present. Okay, it doesn't matter how much you increase the substrate concentration by, that if that non-competitive inhibitor has altered the structure of that active site, that substrate can no longer bind. Okay, so you're going to get a lower volume, a far lower volume of product, which therefore means you've got a far lower rate of reaction.